A big welcome back to everybody, and welcome back to our SUSE Linux Enterprise Server version 12 training workshop. This is where we are learning Linux the easy way. My name is Jaco Foster, and I'm a SUSE certified training engineer at SABT Tech. My colleagues are standing by to answer any questions which you might have, which is topic related. And should you have any longer questions, please send us an email to suse@sabttech.com. So our agenda for today, we'll be looking at process administration basics and process scheduling. So also quite a lot to do on our servers, and ensure you have server 1 started. Let's dive into our slides. Let's look at process administration basics. Before we can start looking at process administration basics, there are a few terminologies we need to understand before we can continue. So the first terminology is the program. What does that mean? It's an executable code stored on a drive. Another terminology is a process. It's a software component creating an interface to a physical device. Then a task is a synonym for a process. Then a user process is associated with a controlling shell or terminal. Then we get a daemon process. It's not associated with a controlling shell or terminal. Then we've got our PID, which is a unique process ID to every new process started. Then we've got our process priority. One process can take preference over system resources compared to other processes. Then every process is assigned to a unique PID. Then processes can spawn other processes. We call that a parent/child relationship. When we manage processes, we can manage them with certain signals. So here's a whole list of signals which we can manage a process with. You can play with this on your own time. Today we are only going to focus on process signal number 9, which is the kill signal when it comes to our labs. Okay, just a quick look at what layout would be of a command. That will be a kill. Then we need to know the process ID and then the signal which we will be using. In this case, we will be using signal number 9. Keep note of that. We will play with this shortly. With administration basics, there are many command line interface commands which we need to know and we will play with. So we will take this section by section. So you first look at the first section, then we'll quickly practice that, and we'll do the next sections thereafter. So the first one we look at is how can we display running processes. For that, we use the PS command. For a longer listing, you use the -L. Here's an example. We will do PS space -L if we would like to see a long listing for running processes. If we want to see all processes running, then we will only see, we'll use the full format with the CLI for the -EF command. It will look like this, PS space -EF. Important to note that this first command here will only show the running processes for that specific user. Then the next command, we've got a PS -AUX. That will also display all processes, but with that we get a user list, meaning which user is running this process, with the CPU and memory stats for each process. That's a PS -AUX. Then we can also have a look at the complete process tree. That's where the parent and child relationships are defined for our processes. Should you wish to see the process IDs of that, we use the -P option for that. So our command will be PS tree space -P. Then one of the most handy features in our SLES environment is using the command top. That display processes with an auto refresh, and it's sorted by the current CPU usage. Now to quit our top, we just hit the Q button. So let's quickly bring up our server and run this first set of commands. Alright, so we've got our server. Let me open up terminal. Going to maximize my terminal and then zoom in again so you can see better. Great. Our first command that we'll be running is the PS. Let's just first do a normal PS command. So this shows us the standard processes running for our current user. Let's do a long listing format, PS-L. And there we can see our PID, which we were referring to. We can also see which user ID ran this command. Now let's have a look at the next command, which is the PS-EF. So we do PS-EF. And this gives us a whole list of commands, also ran by both users, which is currently a root and touch on our server, or all users for that matter. And what else do we have there? And we've got our process IDs listed over here as well. Then next, let's quickly do the PS-AUX. So we do PS-AUX. So here we can still see all the processes ran by all users. We've got our process IDs over here. Let's scroll up slightly. Let's really see if we can show you the start. There we go. We've got our process IDs. And what we have extra is our CPU and memory usage per process. Let's go down to the bottom so you can see. There we go. So you can see which process is using how much CPU and memory. Great. So then we're going to look at our top command. Let's look at top. And here we've got a live view of how our system is currently performing. And it's got a refresh of run about every 3 seconds at this stage. It's listed with the top CPU usage currently. And there's a lot of options we can use within top. We're not going to go into much detail, and you can go and play with this at home on your own time. So let's press the H button within top. In the H button, it gives you all the help functions that's available to use top. There's many things you can change. You can even do filtering. Let's just try filtering for now. I'm going to hit escape just to quit the help function. And now we see all the processes for root and tux. So let's press the U button and I say, which user do you want to use? So I'm going to say just the tux user and hit enter. And this will sort everything and just show me all the processes for the tux user. To bring back all the processes again for all users, you press the U button again and just hit enter. Do not put anything in there at this stage. And this will clear out our filter and bring up all the running processes. Alright, that was easy. Remember, you can play with this by pressing the H button and you can quickly redefine quite a bit from this. So let's just bring back our slide. So now we look at the background jobs. We can start a task, also known as a job, directly in the background by using the ampersand. So the format will be our task space ampersand. In our exercise, we will be running xis space ampersand. We can also pause the current running task and put the job in the background by using the Ctrl Z, not an uppercase Z, just a Ctrl Z button, and it will place the current job in the background and it will pause that job for us. So it will not continue running and using any system resources. It will be in a pause state. Then we can view all running background jobs by using the jobs command. Should we wish to continue running a background job in the background, then we use the bg command. Now you can choose any command, any background job to run in the background by just choosing the job number. If you only choose bg, it will continue to run the very last job that was paused. Then we can continue the last placed job from the background by just pressing the FG buttons or running the FG command, and it will bring the last placed job in the background back to the foreground. And we can also bring any other job to the foreground by using the job number alongside the FG command. So it will be FG space job number, and we'll bring that specific command to the foreground. Let's quickly try that on our labs. Let's try to find my labs. Here they are. Okay, and I haven't quit that yet, so just hit quit and clear our screen. I hit Q for quit, and I've cleared my screen. So our first task is to open up XIs. So let's first open up XIs without an ampersand. Let's see how it looks like. So we go XIs and we hit enter. And now we've got our process running here in the foreground. Little funny eyes following your mouse all over. But the problem is I cannot continue to use my terminal. Anything I put in there has no purpose. So let me hit Ctrl C to cancel this running process. Now I've got control back over my terminal, and you see XIs has disappeared also. I think for this I'm just going to bring my screen and just make it a little bit smaller so we can start stacking our processes here on the right hand side. Okay, so let's run the same command. We go XIs, and this time we use an ampersand, and this will directly launch the program or the task in the background and give us control back to our command line. There we go. So there we've got our XIs running there on the sides, still following my little mouse over there, and now it is running in the background. Let's try opening up XIs again, but this time we are not going to use the ampersand. So we go XIs, you spell it right, XIs, no ampersand, and let's just see how my eyes running over there. And this time I'm going to go and I press the Ctrl Z button to pause the current job. So we know the first one is an active job running in the background. The second one we still has control over our terminal. So I'm pressing Ctrl Z. Alright, so it says now it's stopped, meaning it's paused, and let's see. Oh, only one of them are actually still following me. So we've got two processes, just the last one that's following me. So let's run the jobs command to see what jobs is actually running. And now we can see that there is a running job, which is my first one. And then I've ran the XIs ampersand, and then there's a stop job. Now you will also see this little plus and minus over here. The plus indicates that is the next command that will be brought to the foreground should we just hit the FG button, or even if we like to, let me see quickly, or if we just like to continue the background job. So let's try running the background job, but let's do another XIs just to show you the difference. We go XIs. We've got XIs over there again. I'm going to run it. Now we've got our third one. I'm going to put it in the background, so we've got Ctrl Z. So we only have one active at this stage. Do you see that? I'm running jobs again, so you can see that as well. So now we can see that the minus and the plus have shifted, that the plus is now on the third one. So that's the job that will continue running should we give that command or bring it to the foreground with that command. But we can also see that there's a minus. That minus means that's the next job that will be brought to the foreground should this job number 3 be killed. Then that will be the next one taking over the plus sign for that matter. Okay, I hope that was clear. So let's quickly do our BG command. So we expect, if we run BG, we expect the plus to pop up. But we want to be more accurate and say, please bring to us, or please continue the background job, but not number 1 in this case. Let's do number 2. I want this one to start working, not the last one. So we go BG 2. And that should start running that in the background. So have a look, that started running. So we skipped the last one to continue. So let's go jobs again and see what it looks like now. So now job number 2 is active, it's running. You can see that. Okay, and we know that the last job is set with a plus to continue should we bring that to the foreground. All right, so let's do that. Let's do just a normal FG and not a number this time. Just FG. And let's see what happens. Oh, there it started working. But we lost control over our session, our terminal session again. So let's go Control Z to put number 3 back in the background. So what do we press if we want number 3 to continue working? Yes, we go BG number 3 and we will set that to run in the background. Let's see if it's working. Great. So now we have all jobs running and we can press the jobs key to see if all of them are currently running. Fantastic. If you close any of them off, they will just close off and we can continue running with the rest. Now let's have a look at our next set of processes or commands within a command line. Here we've got our process relative priorities. Now this is where we can set the relative priority of a process to -20 being the highest and 19 being the lowest. What does this entail? This means there are 40 positions for process priorities. But if I count 20 plus 19, that doesn't give me 40. So how do I get to 40? Process 0 also counts as a number. So if we calculate 20 plus 19 plus process 0, we get 40 positions. So what do we do with a process priority? Why would we like to do that? We would like to set our process priorities to either lower or higher to determine if we want to give more resource preference to a certain task than another task. So we can set the resource preferences by using the nice command. So if we launch a task with a specific relative priority using the -n and the number we would like to add to that. For example, we do a nice -n and say we want to have this as a process priority 4. 4 is lower, meaning we're going downwards, going to a lower process priority. Then we can do a renice. Now a renice can change a process priority. So we can change a running task relative priority. For that we need to know what is the process ID for that specific task. So we need to first run a ps command to find the process ID. So let's quickly have a look at a -15. What does that mean? That means that's got a higher priority. But something we need to note is the only user who can allocate more preference to a process is the root user. So your normal tax user, which is a non-privileged user, can run a process at, in this example, as a 0 process priority, and it can renice only to a lower number, never up. So once you have changed your process to a lower number, it will not give you the option to change it back up. You need to get a system administrator, for example, root access, to be able to change your process again to a higher value. Or you have to quit the process and relaunch it, and you'll relaunch it at a 0 priority. Okay, then what we can do is we can also kill processes. So we can send a signal to a specific process ID. In this case, 9 equals kill. And we can kill a specific process. So again, we need to know what is the process ID. Okay. Then we can do a kill all. That means everything that the process that's got a specific name, it can be killed. And we can also forcefully kill it by the signal 9. So we run our kill all xis space 9 to kill all running processes with that name. Let's quickly try that in our labs. So here we still have our 3 processes running there. We can see them. So our first one will be to do a nice of XClock. Okay, so we haven't run XClock yet. So let's first run XClock now, and we'll do that. Let's do a nice. And we want to start XClock with a specific process priority, which is 4. Sorry, minus in 4. And we do XClock. And there we've got XClock running at a certain process priority. What's our problem? Yes, XClock is in our way. We cannot get access back to our terminal. So what do we do to fix this? We run Ctrl-Z. But now the clock will stop. The clock will stop. I'm just going to put it down here for us. And that's a problem, because we don't want our clock to stop if we want to view it. So let's quickly bring it up, and we know it's got a little plus button over there. So all we can do is just BG, and it should continue running that clock. Before we do that, I'm just going to wait. My server time is this at the moment, so I'm going to wait for it to quickly switch over at the bottom, so we can see that it will continue running once I run the BG command. Then after this, we're going to do a re-nice of our XClock. So we're first going to see what's our current clock ID like, and then we're going to do a re-nice of our clock. For that, we'll need to first find the current process ID. To find the current process ID, we are going to run a long listing of the processes. Let's see how far our command is. There we go. So it's now minus 1 minute on, and I'm going to run just continue the BG, continue the background process, and automatically my time shifted over, so we now know it's running. We can do the jobs command just before we continue to see. Great, and we can see all the jobs running there. Now, next we're going to quickly do a PS minus L to give us a process listing of all our processes. Now, mine's a little messed up because of my screen size, but here we need to find the XClock process. And here I can see my XClock process running over here. Do you see that? So my process ID is 61341. Yours should be different. And then we need to see what is our nice like, our nice value. So here's the NI. Do you see that? That's our current nice value. So all our other processes, here's all the XIs, started at a process nice value of 0. Except for XClock. XClock started at a process value of 4. Okay, so let's try to re-nice it to a minus 15. So we go re-nice, and we go minus 15, and our process number, ID, So mine was 61341. 61341. Yours should be different. Search for your process ID. Now I'm going to hit enter, and I've got a problem. Failed to set a priority for that process. Permission is denied. Why? Because we cannot take up a process to a higher level. Minus 15 is higher. We need to bring it lower. So let's do exactly the same, but this time we do it as a 15 process, not a minus 15. Let's try to do that. And it says all priority is full, new priority is 15, 1-5. Mine just cut off there. And let's do a PS minus L. And you'll see my nice value has changed to 15. Let's try to bring it back up again. I've got I know already my process ID, so I want to make that this time a 5. I've just changed it. I am the tax user, so I've just changed this process to be a lower priority. So obviously I should have the right to put it back. And the answer is no, you do not. You do not have the permissions. Only a root user can do so. So I can just kill the process, restart, and I'll have a process nice value of 0 again. So why is this important to be able to manage our process priorities? We might have a very busy server and we need to allocate some bandwidth, if you want to call it that, or processing performance to a specific task within our server. For example, a backup job that needs to be completed urgently. Then we can process that backup job quicker than other tasks and give the available resources to a higher priority to our backup task to complete sooner. Okay, so let's quickly close my XClock. It's in my way. There we go, it's closed down. Our next command we're going to run is to kill a specific process ID. Now, I could have killed my XClock, but let's go kill one of the other XIs. There's a nice one. I'm going to take my first XIs and I'm going to kill that off with my process ID over here. Do not make a mistake. This is a parent process ID, just a parent, and then your process ID. Now, just to quickly explain, a parent process ID should usually be my shell itself, because it was launched from my shell. There we go. There's my main process, and that was my bash shell which I have launched. This is this terminal window over here, and that terminal window in turn launched my process itself. That's why I've got my parent process listed over here. Okay, so our parent-child relationship is over here. There you can see that. Okay, so let's quickly kill that. We do a kill, and that process ID for XIs is 61296. And we can kill it. Minus with the 9 signal, and this should kill it right off. So which one do we expect to kill? I would say the top one, if I remember correctly. And gone it is. So it's terminated that process. Let's do a jobs to see we only have 2 jobs left running. Okay. So the next one is to kill all running processes. Okay, let's try that. Let's do a kill all. And this time we don't know the process ID, but we're going to use the name because we know what the task name was. Also a 9 signal. And let's see if it kills the remaining processes. And gone they are. Let's look at our jobs. And there are no jobs running anymore. Now, just for the fun here of, let's do something different, which is not listed over here. I'm going to open up 2 XIs again. So let's quickly do that. We go XIs, and we do it in the background immediately. Let it run, and let's do another one. So we have 2 running already. So what happens if I close my terminal? All right, everyone take a guess. Think about it a moment. Let me list my processes. So we know that there is a parent process for XIs. I've mentioned that before. There's my parent process name. So this process launched these processes. So if I close my terminal, then the parent process is gone, which is my terminal. So this should in turn kill my child processes. Okay, just keep that in mind for future reference. I'm just going to open up my terminal again and just put it back where it was. Okay, let's continue to the next slide. Now we're going to look at process scheduling. Question is, why process scheduling? If we are able to schedule processes, we are able to run a process at a certain point in time on our server. For example, backups. So there's a use for this. We use cron tab in SLES for our process scheduling. We first are going to look at the user cron jobs. So a cron daemon, and the daemon is located at user/sbin/cron, allows you to schedule jobs that will be carried out for you on a regular schedule. The command we use is cron tab, but cron tab needs to be accompanied by an option. So to edit a user's cron tab, we use the -e option to do so. This will open up the cron tab in a very familiar environment that we call Vim. So we have used Vim already, and that's our text editor. So every cron tab for each user that's created will be recreated within the vars pool cron tabs directory. Inside the tabs directory, you will find the file for each user. We can also list each of these the cron tab for our user by using the -l command to list our current cron tab. Should we wish to clear out a complete cron tab, we just use the -r option. Now, your normal user do not have access to this directory, for this is a privileged directory. You will be able to see other users' details in there, other users' cron tabs, which we don't want. So you need to be a privileged user like root to be able to view the cron tabs in there. And that's why we don't usually go into this directory to go and change any cron tabs. We use the -e because this gives us access through the cron tab daemon to edit that specific file which belongs to this user. So what do we find within our cron tab, and how do we define our jobs to run at certain points in time? So this is a snippet of what it should look like to run a basic cron tab or cron command, cron job. So we've got 5 fields here which indicates the following, and all of them can be marked by star. Then it means it will run just like every moment. But the first one is our minute. So this indicates the minute of the hour that this job will run. So it doesn't mean every minute. This means if the hour clock stands on a 5, meaning 5 minutes past 1 o'clock, then this will run on 5 minutes past 1. And if this was a star, it will continue to run every hour on the 5 minute. Then we can also choose the hour of the day that we want to run this. So here we have chosen 20. So this means this job will run at 8:15 at this stage. And because these are stars, the day of the month, it will run every day because it's not specified, unless we specify it. Then we can also define the year, the month of the year that we want to run this at. And for example, this will also run every month of the year. We can also define the day of the week we want to run the specific task. And again, the specific task will run every single day because it's not defined. Then all we do is we direct the instruction to what we want to do, and usually to a script file will be better. So you have to rather create your backup inside a script than rather scripting it within the cron tab, which is not good practice. So this will show us we are running it from our home, the tux/bin, and then a my_backup.sh. It will be a script we can write there. We're not going to do this exercise, but it is possible to do so. So other examples, if you want to run it at only certain days of the week, you can use a 1 minus or -5, and that will run it Mondays to Fridays. Again, the star will be every month of the year on the fourth on a fourth position. So you can also change this to run only, let's say, 3 to 4 for that matter, and it will only run that the third and the fourth month of the year. The same goes with our day of the month. We can assign that, and then also the hours of the day. You can decide on which hours of the day it should run, and then should you wish this to run every few minutes, you use the * let's say 10 minutes. So this will say every 10 minutes it should run this command, or every 15 minutes it should run this specific command. So let's quickly see if we can create our own cron tab at this stage. Open up our labs. So the first command we have to run is our cron tab -e. Let's do cron tab -e. And now we are inside our Vim editor. So we add cron tab space -e, hit enter, and now it opens up a temporary location for our cron tab. Once we hit save, it will save it within the correct location. So let's add the specific cron tab for us. Let's do that. Remember, this is Vim editor. We first need to enter the insert mode. We are currently in command mode. So we go I to insert, and let's add a 15 space 20, and then a star space star space star. Then what do we want to run? /home /tux/bin /my_backup. Now this file doesn't exist, but we are only using this as an example. So your output should look something like this. So this job will run at when your server time reaches 15 minutes past 8 in the evening. This job will run, and it will run the script within this position. Okay, to save our cron tab, we hit escape to go back to command mode. We go : right quit. We need to save the cron tab. Hit enter once done. Okay, so now it states cron tab. We are installing a new cron tab. So next, let's quickly see if there's a cron tab listed. We go cron tab -l, and it states yes, we have a cron tab listed. There is our command to run within our cron tab, and we cannot edit this file. We're not allowed to edit that file, if you remember correctly. Let me just quickly go back here. There the file is located now within this directory, the tabs directory. So we're not allowed to edit that file directly. We need to physically run the cron tab -e again. So now we can also remove the cron tab. You can either go and run a cron tab -e again, and you can go and delete it, or we can just physically do a cron tab -r, and we'll clear out the complete cron tab. So let's run that. Cron tab -r will completely erase the cron tab for us. And let's do a -l again to see if that was done. And there's no cron tab for the user tux at this stage. Good. Let's continue with the next cron tab. So the next cron tab we look at is the system cron jobs. So with this, we've got we've got our daemon that needs to run certain cron jobs for us. Or not even that, we also have our administrator which would like to run certain cron jobs for system purposes. So the location for the cron tab is the etc/cron tab. This is the location of system cron jobs. This task can be run as a specific user. So this will only be a privileged user which will be able to do this for us. Then the system has 4 other cron job locations which we can utilize. So the one will be the etc/cron.hourly, and this will run whatever jobs is within that folder, it will run that hourly. And then we've got a daily, which will run that at the beginning of every day, meaning 12 o'clock. And then weekly, when the start of the week on the system, our week starts at Monday. And then monthly, obviously the first day of the month, it will run the specific cron job for us. So everything or any script that's within this folder will be run by the cron daemon. Okay. So here's an example of what it should look like when we are running a system-related script. So this specific one will show us when this must run. Now this one states that we must run this script every 15 minutes. That means no hour defined, so it doesn't matter which hour, doesn't matter which day, doesn't matter which month or year or week. Everything, it must run it every 15 minutes of the day. So it will start at 0, which is the first 15 minutes, and it will start at 15, and then 30, and 45. And the next will be our 0 again, because it runs from 0 to 59, not a 60. Okay. Then we can define as who must the cron job be run as. Now in this case, it's root. And then you can define what. Now you'll see here is not specifically a script defined, but it should do something specifically for us. So you can define the what after that. Let's quickly open up our labs and do those 2 commands. So let's first clear our screen. And now we're going to do a cat of /etc/cron tab. But hang on, there's a problem. Why can't we see this? Because this is a privileged user command. So we cannot do this. So we can do a sudo, then cat /etc, then /cron tab. And that should give us the details of the current cron tab, the system cron tab. Okay. Then we've got another one that we can look at is the etc/cron hourly. Let's quickly do that. Again, we have to do sudo. Then we do a cat of the /etc/cron.hourly. Okay, I'm going to hit enter on that. Now, let's have a look. Will cat work on this? Oh my word, cat is a directory. And that's what I wanted to show you. It's noted here as a directory. So we can't do a cat, but we can do an ls, because we want to list the directory, the contents thereof. We said any script in there can run. And there we go. We have one script in there. You can cat if you'd like to do so. So I'm going to use the cat and then the SUSE snapper, and there is a script. There you can see the contents of the script for the specific system cron tab. So, okay. Or the system job is a better description. We don't have to do the others. The others will just have more scripts on a daily and a weekly and monthly that you can do on your very own time. Okay, let's continue with our process scheduling. So another method of process scheduling is using the at daemon over here. So with the at daemon, we can run the at command. So the purpose of the at command is to schedule a task. Once we enter the at daemon, we can add a list of tasks to it. And once we are done adding the list of tasks, we can press the Ctrl D and it saves and exits your command input. You can also specify an optional script file and to run a script file at a specific time with the at daemon. We can use either at or batch. It will give us exactly the same output. So you will have the option of running at space -f, which is the file, and then your file name, and then which time you would like to run it at. We'll not be doing a script file in this case, but we'll be running a test for at, let's say at 1 o'clock for that matter. Now, another command we can do is the ATQ command. We can view what scheduled tasks is for a current user, for the specific user. And we need to note the task number if we want to make changes to it. We can also remove a scheduled task by using that specific number that we've noted with the ATQ command and adding that to our at command, remove rm, atrm, and then that specific number to remove that command. Then another thing we should do is the at daemon is not always started by default. So the command we can run to start it for this instance, if it's not already run, we can first check the status thereof. We use the systemctl to communicate with the systemd on our system. So the command will be systemctl status space the atd.service, and then our systemd daemon will see if the command is operational. We can then start the at daemon if it's not started by systemctl space start space atd.service, and that will start the atd daemon to run this command for us. We can also define if all users are allowed to define jobs or not. So one of the functions is definitely if you want to allow a user to run a certain job, then you must add the username to the at.allow file, etc/at.allow file. You can also deny a user by just adding its name to this list. Important to take note, the deny takes preference over allow. So should the user be listed tux in allow and deny, it will be denied because it takes preference over the functionality. Okay, let's quickly run that on our server. So the first thing we do is we clear our screen so we can have a clear canvas. So before we start, we need to see if this service is running. So now we have a few services, and I think it's better for us to run this as the root user. You have less sudos to do. So let's do a sudo. Can you remember how to change to the root user? Either -i or su minus. And that would change you to the root user's privileges. There we go. So now we're root user, it's indicated by the red. To check that, who am I? And we can see we are definitely the root user. So our first command that we have to do is let's first check if our service is started. So we go systemctl status atd, and I just tabbed that out. Let's see, mine is active and running. I'm just going to stop mine. So if yours is not started, let's see what it would look like. I've stopped my service and let's do status. So should yours show active the activity is inactive and it's dead, then we still need to start it. So let's quickly start it. We go systemctl, and we just do a start, and that should start our @daemon, and we can just go look at the status to see if it's active and green. So all I did is just I ran the status command again to see if it's active and running. Great. Now that we know it's running, we are able to perform those functionalities. Let's just clear our screen again. Clear. Our first command will be we need to run a specific command at a certain time. So before we can run a command, we need to know what date is our system. Now my server date is now 05:44 minutes. That's in the morning hours somewhere on April, guess, Monday. Okay. So let's quickly make a run that command. Let's do a @, and I want to be able to view this command in a few moments. So if my time is now 05:45 basically, I'm going to run it at 47. Let's make it 47. At 05:47. So we don't have a lot of time. I'm going to change that to 48 because I want us to view something with this. Okay, so now we can add detail to that, and let's run a finger command, and we output that to our /var /lock/messages. You need to type this out. Messages. So this will put whoever's logged onto the system to that file, which is our log file, and we hit enter, and we press the, can you remember again which one it was? The Control D to save our input. So we press Control D to save, and now it's set. Let's quickly do ATQ to see if it's set, and there we've got the job that should run within a few moments. Now I'm just going to minimize this, or just going to put it that way, and just open up another terminal, and here I want to tail, I don't think we should be able to do that, we're going to go sudo, and I want to tail -f our var lock messages. Now at the very bottom of that of the var lock messages, and this should be able to show us when a command runs. I could have done it in there as well, but I wanted to show you what it looks like if that command runs automatically. Okay, so while we're waiting for that, we can also go and remove the command. So I'm roughly a minute ahead. Let's look at our system date. Okay, and I'm only a few seconds, about 45 seconds still, and then it should run that command. Let's just make that a little smaller. Go date again. I'll close. Another 30 seconds or so. So once this command has run, it should automatically exit our queue. Is that correct? We'll see that in a moment. Another few seconds, and have a look at the screen over here. And there something ran. So let's see what happened up there. There is our finger command that we asked to say which users is logged on to the system currently. So it ran that command with the @daemon. Very good. So we can Control C to end the tail command. To show again the command which I ran there was the sudo space tail -f to follow. I wanted to follow that file lively. and then var log messages. Okay, let's close that down. Let's open up my terminal again. And now let's run the ATQ to see if there's still a command available. When we ran it the last time, there was a command supposed to run. And ATQ currently is empty. So let's see if we can delete a scheduled task. So I'm going to run exactly the same command again. But because I know, where is it? Somewhere here, I've missed it now. There we go. So because I know I've missed this time is now passed on my server. I hit enter, and we're going to run exactly the same command. We go finger, and we're going to append the log file. So var /log / message. You can't type it out. Messages. Come on, there we go. Messages. So this will run a command, will append the log / messages file again. And once we are done, we press Ctrl D to save. But now, because we have missed that time, it automatically changes this to tomorrow for that time. So it will run that by tomorrow. So let's see if we can list it first. We do ATQ. We've listed that. And let's see if we can clear it, because we know that it is process schedule number 10. And we do just check what is yours. Mine is number 10. That's ATRM, and put your number in there, not my number. Mine is number 10. And hit enter. Great. So we've ran a command. If we do ATQ now, it is clear. So this is just another way of doing process scheduling on our servers. Now this brings us to the end of today's session. I trust you enjoyed the training with me today and you found this informative. We now have a few minutes to quickly answer some questions, and for longer technical questions you should mail us on suze@sabttech.com. I am Jaco Forster from SABNT Tech, and I will see you here tomorrow again, same time, same place. Have a good day.